Good morning, students. This is a lesson from yesterday's class that we covered during our math block. If you weren't there, you might want to watch this to make sure you did your page correctly. And then this is for the math lesson today. Okay, so this is page 105 and page 110. I'd recommend doing all the questions for both pages. You could skip a couple from 105 to 109 if you'd like, but it shouldn't take you very long if you do them all. Okay, so we're talking about congruency. We're talking about different ways to demonstrate congruency. The rules of being congruency is they must be the same size. So the shapes must be the same size. They must have all the same lengths and they must have all the same angles. So what we're saying in general is the same size and they have the same shape. This part determines shape. That's determining shape, and then size is just as it is. Okay. Now, how do you demonstrate congruency? There are three different ways that we demonstrate congruency. So what we do is with this shape, I'm showing them that they're congruent to each other because I am demonstrating angles are congruent to each other and side lengths are congruent to each other. So the way I do that, I can determine any of the angles I want to start off with, but I'm going to start with this angle. I'm going to give it a one-line curved line. And then I'm going to say, okay, well, this is the same as this. So I'm going to mark that. And then I'm also going to say, well, actually, this and this are the exact same as well. So I'm going to do the same marking, which is just one curved line. And then I have a 90-degree corner right here. And a 90-degree angle, I make a little tiny box, and that demonstrates that this is a 90-degree angle. It's not perfect, but the idea is still the same. Now, in terms of side lengths, what should I do? I demonstrate side lengths are equal by putting a little dash halfway through the line. And as I get more lines, I add more dashes. So this is the same length as this, which is the same length as that, and then this is its own length, and this is its own length. Right? Now, this demonstrates that these two triangles are congruent to each other. I know they're not perfect, but the idea is because the markings I have laid out, we have to trust the markings and say, okay, these are congruent. Now, I can have triangles that are different lengths. This one is 3 different lengths altogether, which is a scaling triangle. And the way I demonstrate that is I put a single line here, I do a double here, and a triple here, because these are their own different angles. And then I demonstrate that by doing this same idea. Okay, and then side lengths 1, 2, 3, and then 1, 2, 3. So this is me showing that this is also congruent, even when I have more angles. I can go more and more if I want to. Ideally, we're not going to do a question that has 5 different angles that are all different sizes because that'd be a lot of space getting covered. But we could do that if we wanted to. Now, let's look at these two triangles and understand how could we name them. So this triangle I named ABC, and this one I named it DEF. Now, in our mind, this one sounds nicer, but it's actually incorrect. And the reason it's incorrect is because my first triangle tells me the orientation and the direction that I'm going to name my shape. Okay? So I need to make sure that I'm going from the same angles every single time moving the same direction. Moving from one angle to the next angle in the same order, not necessarily direction. And I'm going to talk about why that's different and why I changed that. So this triangle actually is ABC, and if I want to say that these are congruent to each other, I should actually say in the correct order DFE. Okay, and the reason I did that is because A, B, C, I went from this angle 1, 2, 3. That means I need to do the exact same thing here 1, 2, 3. I can't go like this direction just because it sounds nicer, because that's not true. This triangle is ABC, and this triangle is DFE. Now, the reason we do that is because when we have these congruency statements, we can now make statements about the entire triangle as a whole. So I can say, okay, well, angle A is the same as angle D, and line BC is equal in length to line FE, right? Now, I could make a mistake here and say, okay, well, I'm going to say that if I use this one, I'm going to say, well, angle B is equal to angle E, because I wrote it down this way, right? A, B, C, D, E, F. And that means that this angle is the same, AD. That means BE should be the same, and CF. However, if I look at my triangles, this is not true anymore. Okay, so that's why it's really important for us to make sure that we're doing the correct orientation and the same order. Now, let's go to the next page. So I would work through, I do most of the questions. You can skip the occasional one if you feel like you're feeling quite confident. What I did with the other students is I'd work through every single question, but just do the first part. So instead of doing A and B, I'd just do A. For question number 7, I think we only did 2 of them, A and B, instead of C and D. So you can sort of minimize some of your work, but I would cover each question that's listed. Now the next page, 110, it's just going over the same idea, which is just reevaluating the idea of congruency. And congruency is it must have the same size and it must have the same side lengths and angles, which is the shape. Now that says nothing about the actual orientation of the shape. So what I mean by that is I have two triangles here. Okay. Now this, I'm going to show something different actually. So these two angles are the same, right? These two angles are also the same. And I'm actually going to leave this one blank because by leaving it blank, I'm actually saying that these are two the same. It's kind of a weird thing. I could put 3 here if I wanted to, but I could also leave it blank because as soon as I start recording one angle, that means I'm going to record all the angles. So I'm going to leave it blank. This tells me that these two are the same as well. Now side lengths, I could say this is equal, and this is equal, and this is equal. All right, so the rules of congruency, are they the same size? Well, yes, they are. Are they the same side lengths and angles? Do they have corresponding side lengths and angles to each other? Yes, 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 and yes. Okay, so that means that this is congruent, even though they're reflections of each other. So what we can understand is orientation does not actually matter about congruency. It's all about size and shape, or side lengths and angles. Now these two right here, they have similar angles. So I could record these angles and say, okay, those angles are the same. Those angles are the same. I'm going to leave this one blank and say these angles are the same. Now the issue with this is they do not have side lengths that are equal. So if I put a little dash here, I'd have to put a double dash here. And this is going to be a triple dash, and that's going to be a quadruple dash. And then this one, it's going to be 1, 2, 3, 4, 5. This is going to be 6. 1, 2, 3, 4, 5, 6. Whew. Right? None of these side lengths are the same to each other. So I can't demonstrate, I can't say that they're the same. So this is not congruent. Right? So this should be covering page 110 and 105 to 109. If you have any questions, please come to the math block and I will be there helping out people with any sort of issues you have. Have a great day.